Okay, practice test number 3. Number 1, we have this triangle that we're given. Right there. This is our reference angle. We've got side K here, side D here, and side M here. And what we need is to list our 6 trig functions. Okay, so the first 3 are sine, cosine, and tangent. And I'll put the theta here. So sine is opposite over hypotenuse. So that would be D over K. So D divided by K. Cosine is adjacent over hypotenuse. So that would be M over K. And then tangent is the opposite over the adjacent, which would be D over M. Oops, M. Now, the inverse of sine is cosecant. So cosecant would just simply be K over D. And then the inverse of cosine is secant, and that would be K over M. And then the inverse of tangent would be cotangent, and that would be M over D. So those are our 6 trig functions from that triangle. Now, number 2, we are given the angle and we are asked to find the ratio. So A is sine of 50. So this is just, type that into your calculator. Make sure you're in degrees. Sine of 50 is 0.766. So A is 0.766. Cosine of 35. Cosine 35 is 0.819. So B is 0.819. And then we have tangent of 40. So tangent 40, 0.839. And then for D, we've got secant of 60. Okay, secant right there. Secant is the inverse of cosine. So if I said secant of 60, there's a couple of different ways you can put this. In your calculator, you can write it like that and then hit the inverse button. Now your inverse button is going to look something like that, or it might look like that right there. Another way to do it, which I would think would be a better way to do it, would be to understand, I understand that secant is the inverse of cosine. So what I'm going to do is I'm going to write 1 over cosine of 60. This is the way I would do it right here. And that is equal to cosine is 1/2, 2. So this to me is a little bit of a better way to do it. It seems to make more sense doing it this way. All right. Now, for number 3, what we're given is we're given the ratio and we're asked to find the angle. So sine of angle A is equal to 1/2. So the way I will type this in my calculator, because I'm asked to find the angle, I will use arcsine of, and then I will use the ratio, 0.5, and that will equal A. and type that into your calculator and you will get 30. Then arc cosine of 0.45 equals angle A, and that is, I don't know that off the top of my head, arc cosine 0.45, 63.3. 63.3, well, of course, degrees on both of those. All right. So that was number 3. Number 4 is one that I wanted to really spend a lot more time on that, but it's kind of hard to do it online. This is, let's take this triangle right here. There's my reference angle. There's my radius, my y, and my x. Now, when side y is equal to side r, what is the angle? Oops, sorry, this should be angle 1 right there. What is angle 1? Okay, so when the angle increases like this, it keeps going up. Eventually, side y is going to equal side r. So if I draw it like, let me see if I can represent that. I need to write the original angle, and this is in an xy plane, this being y, x. As this angle increases so that y and r become the same thing, we're going to be right up here, right on the y-axis. That's where the angle will be. And at that point in time, angle 1 will be 90 degrees. And then it says, what is the sine of angle 1? Now you can type in your calculator sine of 90 degrees. I realize that that's not really a triangle at that point, that it's just a straight line, but we can still calculate that angle and all of the trig functions of 90 degrees. But if you understand that the sine is the opposite, which is y, over the hypotenuse, which is r, if they're equal to each other, it's going to be 1 over 1. And so the sine of 90 degrees will equal 1. Now, if it went the other way, if it went down, when x is equal to r, that means that the angle would be down here, and the angle would be 0 because it would lie flat on that. And so the cosine deals with the adjacent and the hypotenuse. So the cosine of 0 degrees is equal to 1. The sine of 0 is equal to 0. And the cosine, to just kind of finish that thought, this was the sine of 90 degrees. The cosine of 90 degrees is equal to 0, because at the point when it's up here, the adjacent side is gone. All right. So let's take a look at number 5. So here we're looking for the angle. Once again, when we are given, that's angle 1, when we're given 2 sides. So let's write this one out too. 15 and 4. So this is very similar to number 3, where we were given the ratio as a decimal. Now at this point, we're given the ratio as a fraction. So We're looking for this angle right here, and we have the opposite side and the adjacent side. Opposite and adjacent, that's a tangent function. So I can say that the tangent of angle 1 is equal to 8 over 11. Now remember, I'm looking for the angle and I have the ratio, so therefore I will use the arc tangent of the ratio to find angle 1. And so on my calculator, I type in arc tangent, that's the second function in tangent, and then 8 over 11. It's the same thing as finding the angle when given the ratio as a decimal. And it looks like angle 1 is 36 degrees. Okay, so now for this one, I look at my sides that I'm given, and I'm given the opposite and the hypotenuse, and that is a sine function. So the sine of angle 1 is 4 over 15. That means that the arc sine of 4 over 15 is equal to angle 1. So arc sine, second function sine, 4, 15, 15.5. So that angle is 15.5 degrees. Okay.